about Sohcahtoa. What is Sohcahtoa, may you ask? Sohcahtoa is a way to solve for sine, cosine, and tangent of an angle. So first we're going to find the sine, cosine, and tangent of angle A. So stands for opposite over hypotenuse. Opposite over hypotenuse. So I label the triangle. This is your hypotenuse, this is your opposite, and this is your adjacent. Since we're finding sine of angle A, what we're going to do is sine equals opposite over hypotenuse. So the opposite in this example is 21. So you will do sine equals 21 over your hypotenuse, which is 29. Now we're going to find the cosine of angle A. Cosine equals adjacent over hypotenuse. So cosine equals adjacent over hypotenuse. We know that your adjacent is 20. So cosine equals 20 over h, which is the hypotenuse, 29. And this is your answer. Does anyone want to come up to the board and find tangent of angle A? Emily, come up.
Okay, so tangent of angle A. You know that tangent is opposite over adjacent. So tangent of angle A would be 21. So tangent of angle A would be 21 over your adjacent, which is 20.
We just learned the first 3 of 6 trig ratios, sine, cosine, and tangent. Now I'll be teaching you the other 3, cosecant, secant, and cotangent. To find the cosecant, you would do hypotenuse over opposite, which is equal to 29 over 21. To find secant, you would do hypotenuse over adjacent, equal to 29 over 20. And lastly, to find cotangent, you would do adjacent over opposite, which is equal to 20 over 21. As you can see, cosecant is just the opposite of sine. Secant is just the opposite of cosine, and cotangent is just the opposite of tangent. Now that we know the basics of Sohcahtoa, we're going to learn how to find the tangent of angle 30 without knowing all the sides. Since we're finding tan of angle 30, we're going to do tan of 30, which is equal to opposite over adjacent, which is equal to 2 over your adjacent, which is x. Find tan 30, you're going to put tan 30 over 1, and then you're going to cross multiply. When you cross multiply, you get x tan 30 equals 2. And you want to get x by itself, so you divide by tan 30 on both sides. What you see here is that there are 2 tan 30s, so they ultimately cancel out. And then you get x equals 2 over tan 30. And then after that, you're going to plug 2 over tan 30 into your calculator, and you're going to get that x equals 3.46. 3.46 is tan 30. That's how you solve tan 30. Now we're going to use inverse trig functions to determine the measure of an unknown angle. So now we want to find the measure of angle x, and to do so we need to determine whether or not we should use sine, cosine, or tangent. In this triangle we're given 2 sides, opposite and adjacent. And in tangent, we use opposite over adjacent. So we're going to use tangent to solve for angle x. To find tangent of angle x, we're going to do opposite over adjacent. So we know that our opposite equals 300 over our adjacent, which is 400. This ultimately equals 0.75. So since we want to get x alone, we're going to do the tan inverse on both sides. And on this side. So the tans cancel out, and you're left with x equals the tan inverse times 0.75. You plug this into your calculator, and you get x equals 36.9.
And this is your final answer.
Now we're going to use the Pythagorean theorem to find the measure of an unknown side. So we're going to use secant of x and then tan of x. So as we previously learned before, that tan equals opposite over adjacent. Therefore, tan equals 12 over 5. So now we're going to apply the Pythagorean theorem to this problem. So we know that the Pythagorean theorem is a squared plus b squared equals c squared. So our a squared is going to be 5, our b squared is going to be 12, and equals a, because we're finding the measure of angle A. So 5 squared equals 25, and 12 squared equals 144. 25 plus 144 equals a squared. Next, we add up 144 plus 25, which equals 169. So 169 equals a squared. Then what we're going to do is square root both sides. So when we square root 169, we get 13. And when we square root a squared, the square roots cancel out, which equals a. So 13 equals a. So now we're going to use this information to find secant of x. As we previously learned, secant is one of the 6 trig functions. Secant equals hypotenuse over adjacent. So in this case, secant equals 13 over 5. Secant of x, and then tan of x. We're going to use the Pythagorean theorem to find out whether trig ratio is positive or negative. So we're given that cotangent of theta equals negative 5 over 3. You know that sine theta is negative, so we want to find cosecant of theta and theta. So we know that cosecant of theta equals hypotenuse over opposite. Therefore, cosecant of theta equals rad 34 over negative 3. So theta equals tan inverse of negative 3 over 5. When you plug that into your calculator, you get theta equals negative 30.96 degrees. Now we're going to find the 6 trig ratios. So sine equals opposite over adjacent, which is 12 over 13. Cosecant of theta equals a over h, which is negative 5 over 13. Tangent of theta equals opposite over adjacent, which is 12 over negative 5. Cosecant of theta equals hypotenuse over opposite, 13 over 12. Secant of theta equals hypotenuse over adjacent, which is 12 over negative 5. And lastly, cotangent of theta equals adjacent over opposite, which is negative 5 over 12.